All right, so in this video, we are going to look at some examples of free body diagrams and how to draw them. So first thing I'm doing is I'm switching over to my tablet so we can look at how we draw these, so we can draw them together. And we're going to work through all 5 of these examples. They are in your notes. All right, they are in the slideshow and they are in the notes. But we're going to work through each of these one at a time. So let's get on this. Let me turn on my drawing tool. All right, so for number 1, the first thing we want to be able to do with any free body diagram is we want to make sure we are representing our object, and we can represent our object as either a dot or a box. All right, so let's just focus on representing objects as dots. So we need to look at this, and we're going to say we have a student sitting on a stool. So technically what this would look like is if I've got my stool, it's a terrible stool, but I've got my student sitting on it, right, like that. I want to just focus on the student as my object. So I am going to draw a dot to represent my student. Now, what are the forces that are acting on the student? So since the student is just sitting, there is no acceleration. So what that means is there is no unbalanced forces. All right, so what forces do we know have to be acting on the student when we know that they can't be unbalanced because the student is not accelerating, the student is just sitting there? Well, the student is an object that has mass, so we know that there is a gravitational force. So we can represent that as weight, or we could represent that as Fg to represent the gravitational force. So that is one force acting on the student. But that can't be the only force acting on the student, otherwise the student would be accelerating and falling to the ground. So there has to be some force equal in size but opposite in direction in order to balance out the force of the weight. Now we looked at in the last video a few reaction forces. Big reaction force would be the result of the stool pushing the student up from that perpendicular to that surface of the stool, which we called the normal force. So our free body diagram for the student sitting on the stool would be, we'd have a dot to represent the student, a force downward to represent the weight, and a force upward that is the normal force caused by the stool pushing the student up. All right, so for our second scenario, we have a feather falling from a tree. All right, so if we think about this, here's our tree, and then we've got a little feather falling. It's drifting to the ground, right? So since we know that the feather falling from the tree, we know it's going to have, here's my dot for the feather, we know it's got some weight. So we're going to write in Fg, or remember that's the same as weight. So we can write that in as the weight. But we also know that the feather is going to have that surface area that lets it float down, right? So it's going to float down slowly because there is a force pushing it upward, or pushing upwards against it, which is the air resistance. So I'm just going to call that a force of friction, which is the air resistance. All right, so remember we could call that drag, or we could call that the force of air resistance, FAR. Now notice I don't have the force of air resistance, it's not quite the same length as the gravitational force because the feather could still be accelerating. It may or may not have already reached terminal velocity, which is what's going to happen when this air resistance force and this gravitational force are equal. That's going to make them fall at the same rate. Now, if we look at number 3, we have our feather again. All right, so we've got our feather, but now it's falling in something called a vacuum tube. And what that means is there's no air resistance because we put it in this big tube. All right, it looks kind of like this big old cylinder. All right, this is just a short version. And there's no air inside. So if there's no air inside, what's going to happen to this air resistance? Well, the gravitational force is not going away, right? It's still going to be pulling the feather downward, but there's nothing to push back up on the feather. There's no ability for that friction to be created as the feather moves through air because there's no air. So how we're going to draw this is we've got our dot for the feather, and there is no other force except the force of gravity. This is in free fall because there's no forces acting on this except for the force of gravity. All right, so we do have a couple of additional scenarios to look at. The first one is a refrigerator being pushed across the floor at a constant speed. All right, so this is going to be a little more complicated than just two forces because we have the floor, we've got the refrigerator, and we have a force pushing on the refrigerator. But the refrigerator against the floor is going to push back against the motion that is being applied to push it forward. So we're going to draw that representing our refrigerator as a dot. And we know we're going to have forces acting in the left and the right, but we also have two other forces. We've got a gravitational force pulling the refrigerator downwards, and the floor is pushing the refrigerator upwards. So we have to depict that in our free body diagram as well. So I've got my gravitational force of my refrigerator pulling it downwards, that's the weight, and then a normal force pushing up, that's the floor pushing up on the refrigerator to keep it from falling to the center of the earth. These two are equal but opposite in direction because the refrigerator is not falling in, it's not moving vertically, it's only moving horizontally. So horizontally, we have our applied force. All right, so the force applied, but the friction between the floor and the refrigerator also is occurring there. But the friction is a much smaller force than the applied force, which gives us the ability to push the refrigerator to accelerate the refrigerator. So we have balanced forces that are vertical and unbalanced forces that are horizontal. All right, our last scenario. Our last scenario is a motorcyclist skidding to a stop, and we're going to ignore air resistance for this. Air resistance will be occurring in this situation, but we're going to neglect air resistance or ignore it simply because all of the other forces involved are going to be much more important for the situation. The air resistance force will be minuscule compared to the other forces. All right, so we have our motorcyclist skidding to a stop on the road. All right, so here we have our motorcyclist on the road, and they are skidding. They're traveling this way, but then when they get over here, they are stopped. So that means we have an acceleration. Well, this is a deceleration, so the acceleration is happening that way. All right. So since they're skidding to a stop, they're not trying to force themselves forward so that all of their acceleration, all of their speed is being slowed down by this negative acceleration, which is caused by friction. So representing our cyclist with a dot, there is no forward force because they are not putting power to the forward turning of the wheels. They have the brakes installed or engaged. They have the brakes engaged, so they're not going forward, but friction is causing this backwards force. All right, but that is not the only force acting on the motorcyclist, because the motorcyclist does have weight, so we have to depict that as well. So we've got our weight, our free body diagram has to show that weight, and the road is pushing back on the motorcyclist with that normal force. So we have our vertical situation, our forces are balanced. Our horizontal situation, our forces are unbalanced, and this friction force acting in the opposite direction of the forward momentum of the motorcycle is causing the motorcycle to slow down and then stop. All right, so these are 5 different free body diagrams of different examples. As long as you can identify the forces acting on an object, you should be able to draw a free body diagram for anything. All right, so we have some practice with this that we're going to be doing. We'll do some more examples in class as well. And in the next video, we're going to talk a little bit about design, because you've got a design project that we're also going to be doing. All right, so I'll see you there.